Bismillahirrahmanirrahim. In this lecture, I am solving problem 6.13 from the book Applied Thermodynamics by McConkey. So the statement of the problem is a closed vessel of volume 3 cubic meter. So in given data, volume is 3 cubic meter. Contain air standard with water vapor at 38 degrees centigrade and temperature T1 is equal to 38 degrees centigrade initial temperature of water vapor, which is equal to 38 plus 273 Kelvin, which is equal to 311 Kelvin, and a vacuum pressure of 660 millimeter of mercury. Vacuum pressure means P vacuum 1 initial vacuum pressure is equal to 6 millimeter of Hg, and so we know that P1 is equal to barometric pressure minus vacuum pressure. So barometric pressure is given to us 760 millimeter of Hg. So P1 is equal to 760 millimeter of Hg minus 660 millimeter of Hg, which is equal to 100 millimeter of Hg, and convert this to kilopascal. So we know that 1 millimeter of Hg is equal to 1 millimeter of Hg is equal to 0.133322 kilopascal. So 100 millimeter of Hg mean 100 multiplied by 0.133322 kilopascal. So P1 in kilopascal is equal to 13.332 kilopascal. 13.332 kilopascal. This is P1. Now, and the temperature falls to 26.7 degrees centigrade. The vacuum falls to 560 millimeter of mercury and the temperature falls to 27. So pressure P PV2 final temperature of vacuum is equal to 560 millimeter of Hg, which is equal to, so this implies that P2 is equal to P barometric minus P vacuum 2. So P2 is equal to 760. Barometric pressure is basically 760 millimeter of Hg minus PV2 is 560 millimeter of Hg, which is equal to 200 millimeter of Hg. So P2 is equal to, convert this to kilopascal, so which is equal to 200 multiplied by 0.133322 kilopascal, which is equal to 26.6645 kilopascal. This is P2, and this pressure is at temperature T2, which is 26.7 degrees centigrade, so, which is equal to 26.7 plus 273 Kelvin, which is equal to 299.7 Kelvin. And some constant value are ideal gas constant for air is 0.287 kilojoule per kilogram per Kelvin. R for vapor is equal to 0.4615 kilojoule per kilogram per Kelvin, and required value are mass of air leaked in. Mass of air leaked here from the statement is calculate the calculate the mass of air leaked in and the quantity of vapor that has condensed. Take the barometric pressure as 760 millimeter of Hg. So find mass of air leaked and mass of vapor condensed. Mass of vapor condensed. So per mass of air leaked, first we will find mass of air initially and mass of air finally. So we will find mass of air leaked from mass of air at initial state minus mass of air finally. Similarly, mass of vapor condensed, we will find this from mass of vapor initially minus mass of vapor finally. So first we find mass of air at the initial state and mass of air at the final state. Similarly, mass of vapor at the initial state and mass of vapor at the final state. So for this, first we find the pressure PV1 and PV2. Similarly, PA1 and PA2. So first we find saturation pressure, and saturation pressure are in the saturation curve. So we will find saturation pressure at 38 degrees centigrade and saturation pressure at 26.7 degrees centigrade initially and finally. So initial temperature is 38 degrees centigrade. So we will find saturation pressure at 38 degrees centigrade. So from saturated steam table, at temperature is equal to 38 degrees centigrade. So temperature 38 is not available in the saturated steam table. So we will interpolate. So in the table 35 degrees centigrade and 40 degrees centigrade is available, and we have to find the saturation pressure at 38. So check here, this is 35 and 40. At 35 degrees centigrade, saturation pressure is 5.628. 5.628 kilopascal. At 38, this pressure is required, and at 40 degrees centigrade, the saturation pressure is 7.384. 7.384. So we will do interpolation. So third minus first divided by third minus second is equal to third 7.384 minus first 5.628 divided by third 7.384 minus second PV1. So simplify this and find PV1, which is equal to 6.6816 kilopascal. Similarly, find PV2. This is PV1 at 38 degrees centigrade. Similarly, PV2 at 26. PV2 at 26.7 degrees centigrade. So from saturated steam table, at temperature is equal to 26.7 degrees centigrade. Just like above, 26.7 is not available in the steam table. 25 degrees centigrade and 30 degrees centigrade are available, and we have to find pressure at 26.7. So from the table at 25 degrees centigrade, this is 25 and 30. At 25 degrees centigrade, Pressure is 3.169 kilopascal. 3.169 kilopascal. And at 30 degrees centigrade, pressure is 4.246. 4.246. And we have to find the pressure at 26.7. So do interpolation. Third value minus first divided by third value minus second value. 30 minus 25 divided by 30 minus 26.5. Third value minus first 4.246 minus 3.169 divided by third minus second 4.246 minus PV2. So this implies that this is simple calculation. So find PV2, which is equal to 3.53518. 3.53518 kilopascal. These are the pressure of vapor initially and finally. Now find the pressure of air initially and finally. Now partial pressure of air so PA1 partial pressure of air initially is equal to total pressure minus pressure of vapor. This will be partial pressure of air. So P1 is given at the given data 3.33 22 kilopascal minus 6.6816 kilopascal. So pressure of air initially is equal to 6.6506 kilopascal. And pressure of air finally PA2 is equal to P2 total pressure finally minus pressure of vapor finally, which is equal to P2 is given to us is 26.6645 kilopascal minus PV2 is 3.53 518 kilopascal. So pressure of air finally is equal to 23.12932 kilopascal. Now we can easily find MA1 mass of air initially and MA2 mass of air finally. So MA1 mass of air initially PV divided by RT. So PA1 multiplied by volume of the vessel, R of air and initial temperature. So PA1 is 6.6506 kilopascal. Kilopascal means kilo and pascal is equal to Newton per square meter. Volume is 3 cubic meter, which is given. RA is 0.287 kilojoule. Joule is equal to Newton meter per kilogram per Kelvin. Into T1 is 311 Kelvin. So here Kelvin will be cancelled with Kelvin, kilo will be cancelled with kilo, Newton will be cancelled with Newton, and per square meter and per meter is basically per cubic meter. This will be cancelled with cubic meter. So mass of air A1 is equal to unit will be kilogram. This is in double division, so it will shift to numerator. And MA1 is equal to 0.22353 kilogram. Now MA2 is equal to PA2 pressure of air finally multiplied by total volume divided by R of air multiplied by T2. So pressure of air finally is 23.12932 kilopascal. So kilo and pascal is equal to Newton per square meter. Volume is 3 cubic meter divided by RA per year is 0.287 kilojoule. Joule is equal to Newton meter and per kilogram per Kelvin. Multiply by T2 is 299.7 Kelvin. Kelvin is cancelled with Kelvin, kilo with kilo, Newton cancelled with Newton, per square meter and per meter is per cubic meter is cancelled with cubic meter. So Ma2 per kilogram is in numerator, which is equal to 0.8067. Now mass of air initially and finally is known to us. No, so we can easily find mass of air leaked N is equal to Ma1 minus Ma2. So Ma1 is 0. Sorry, this is Ma2 minus M leaked. So leaked will be found from final to initial. So 0.8067 kilogram. Finally and initially this is 0.22357 kg. So mass of air. So mass of air leaked N is equal to 0.583 kilogram. Now we are finding mass of vapor condensed. So for this we are finding mass of vapors mv1 and mv2, masses of vapors. So mass of vapor initially is equal to PV divided by RT. So pressure of vapor initially multiplied by volume, total volume, R value for vapor multiplied by initial temperature. So PV1 is already calculated by us, which is 6.6816 kilopascal, mean kilonewton per square meter. V is 3 cubic meter. Divided by R per vapor is 0.4615 kilojoule per kilogram per kg. So per kilogram per Kelvin. Joule is equal to Newton meter per kilogram per Kelvin. Multiply by T1 is 311 Kelvin. So mv1 is equal to, simply calculate this. So mv1 is equal to 0.1396 unit is kilogram, because kilo is cancelled with kilo, Newton with Newton, per square meter and per meter is per cubic meter with cancelled with per cubic meter, Kelvin is cancelled with Kelvin, so unit is kilogram. Per kilogram is in numerator. Now mass of vapor finally is equal to PV2 multiplied by V total volume, R of P multiplied by final temperature. So pressure of vapor finally is 3.53518 kilopascal. Pascal is basically equal to Newton per square meter. Volume is 3 cubic meter divided by RV is 0.4615 kilojoule. Joule is equal to Newton meter per kilogram per Kelvin. And T2 is 299.7 Kelvin. Kelvin is Kelvin cancelled with Kelvin. Kilo is cancelled with kilo. Newton with Newton. And per square meter and per meter is per cubic meter. Cancelled with cubic meter. So mass of vapor finally is 0.0766 kilogram. Now we can find mass of vapor condensed. So mass of vapor condensed is equal to mv1 minus mv2, which is equal to 0.1396 kilogram minus 0.0766 kilogram. So mass of vapor condensed is equal to 0.063 kg. So this is the final answer of the problem. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.